Ladies and gentlemen, today we'll be talking about EtherChannel. EtherChannel is a technology that was originally developed by Cisco as a way to pretty much group interfaces together. And yeah, so as you can see over here in this simple topology, if you want to call it that, I have two switches and I have three trunks or interfaces connected together. However, as you can see over here, only one link is fully operational. So all traffic between the two switches is going through this, okay, because of STP. STP is doing its job in preventing loops in the network. So let's say if this link was to go down, then STP would come back and pretty much do its calculation and elect the new link that's gonna be in the forwarding state. So yeah, STP is great, but you can make better use of these links by grouping them together, and this is where EtherChannel comes into play. So if we go over here, basically EtherChannel, what it's gonna do once you configure EtherChannel, you're just gonna group these links together, group them together, if you can visualize that with this, and then they're gonna act as a STP is gonna see these three links as one logical interface, just one. So basically all the ports in here are gonna be in the forwarding state, but they're gonna be acting as one, so to prevent loops. Okay, so pretty much we have two ways of doing EtherChannel on Cisco switches, and that's one is doing it statically, and that's basically turning it on over here, turning it on over here in this section over here, and then coming over here and turning it on there, and then EtherChannel is working. The best way to do it is you have LACP as well as PAGP. PAGP is pretty much Cisco's implementation and it's proprietary to Cisco switches. And then LACP, it's industry standard for aggregating link. Pretty much you have to create EtherChannel using PAGP or PAGP. You have the option to do auto. You have the option to do on one side you can do auto and the other side desirable, or you can do desirable, and either way the EtherChannel should work. The main difference between the two is the auto is just basically waiting for the other side to initiate the EtherChannel configuration or negotiation, whatever you want to call it. Desirable is the one that actually does the initiation. So if you have one configured as desirable here and auto over here, the EtherChannel should form. If you have desirable over here and desirable over here as well, then that should also form the EtherChannel. The next way of doing it using a dynamic configuration is LACP. That for those options you have active and active and passive. And in here, the active makes sense that that's the one that's doing the initiating EtherChannel configuration, and the passive is the one that is just waiting for the other side to initiate. So pretty much if you configure this as passive and this one as passive, most likely the EtherChannel will not be happening. So you gotta use using LACP, you either use active or active passive. All right, some guidelines. Pretty much the interfaces gotta be identical. You cannot be mixing, or you should not be mixing and matching speeds such as fast Ethernet or gigabit Ethernet, and also don't mix like PAGP with LACP. Also you can do, and I forgot to put it on the slide, but you can do anywhere from 2 to 8 links using Cisco switches for as far as aggregating links, up to 8 links. Okay, let's get this configuration started. We're gonna start with switch 1, and we're gonna go here, configuration terminal, interface, range fast Ethernet 0, 1, 2, 3. Okay, so now we're gonna go with shutting the I already shut the interfaces beforehand, so that's a best practice to just shut down the interface before you do any configuration. So we're gonna do channel, and this is what we were talking about earlier. So basically we have active, and it tells you over here. So active is for LACP, auto is for PAC-P, desirable is for PAC-P. So we're gonna start the configuration with LACP, and here what we're gonna use is passive, and that's pretty much it. Then we just do no shutdown, no shut. Then we're gonna move to switch 2, do the same, configuration terminal, channel group, mode. We did passive on the other one, so if we go here, we did passive over here. So on switch 2, we're gonna do active, no shut, and there you go. They're coming up. They're negotiating the. Now we're gonna just go here, convert this to a trunk. So if you do show IP interface brief, you see, there you go, this port channel over here. What we're gonna do is make that port channel trunk, and there you go. Some verification command you can do show, and there you go. So with capital S says it's a layer 2, and capital U says that it's in use. As you can see, the port channel was created. EtherChannel is working correctly using LACP. Now we're gonna do a quick PAGP Cisco's implementation. We're gonna do it really quick. So I'm gonna just clear the configuration on this switch. Okay, real quick, I just cleared the configuration on both switches. Let's configure PAGP, which is Cisco's implementation. Config T interface range. Okay. Three. And then this is where we choose the options that you want to choose, whether LACP or PAC-P. So last time we used LACP, this time we're going with PAC-P, and we're gonna go with auto on this side, trunk, no shut. Now we're gonna move to the switch number 2. So on the last on switch 1 we use auto. This time we're gonna use desirable. We're gonna convert the port channel 1 to a trunk, and just wait. So if you go over here, you're gonna see show EtherChannel summary. You see again capital S is a layer 2, and then it shows here that we're using the PAC-P protocol. That's it. Too easy, right?